So here I brought you a model for an elastic material. This is a rubber band. You see, elastic. Okay? And as a model for inelastic, I will take this rigid blood pressure cuff, which is completely rigid, no stretch at all. And what I would like to do now is to apply these two models on my own leg and measure the pressure underneath these devices. For measuring the pressure on the distal lower leg, I prefer to take the so-called B1 point, which is the point where the muscular part of the gastrocnemius tendon goes into the tendinous part. When I do a dorsiflexion, you hopefully can see that this tendon comes out. So this is the point on the lower leg which shows the maximal increase of circumference by dorsiflexion, so by moving the ankle. And at the same time, there is not only an increase of the circumference, but what you also can probably see is that there is a change of the radius here. By doing a dorsal extension, the tendon comes out and the radius gets more sharp, which will increase in addition the pressure under the device due to Laplace law. For measuring the pressure, we have different kinds of pressure probes. As you see, this is completely flat without any air in it, and I put it exactly to this P1 point behind the tibia and attach it to the skin. And now I take this inelastic model for compression, completely rigid, and put this blood pressure cuff around my pressure probe. And now I blow it up to, let's say, 40 millimeters of mercury. I have now a kind of inelastic bandage with a local pressure of about 40. And this pressure we are able to see on the computer. So it shows us 40 millimeters of mercury. And now I do dorsiflexions. There are high pressure peaks going up to more than 60 millimeters of mercury. And now I just stand up, nothing else. Just stand up, and the pressure goes up to more than 60 millimeters of mercury during standing. And then I do dorsiflexions, and you will see up and down movements of the pressure curve. This pressure level of close to 40 millimeters of mercury corresponds to the leg up position, and this is what we call resting pressure. As soon as we start to move the ankle, dorsiflexions, you see the pressure peaks go up to about 70 millimeters of mercury. The difference between these pressure peaks and the resting position is what we call dynamic stiffness index. This is the difference between the highest pressure peaks and the resting pressure in the leg up position. Then I just stand up, and you see only by standing up the pressure rises from 40 to close to 80 millimeters of mercury. And when I start to move again, you can see again these pressure peaks going up to over 80 millimeters of mercury. So the pressure difference between the standing position here and the leg up position here, this is what we call static stiffness index. This is the pressure just induced by standing up. And these pressure peaks you could call working pressure. This is the so-called working pressure. So resting pressure and working pressure. And you see the difference with inelastic material between resting pressure and working pressure is about 40 millimeters of mercury. Now I take my model for elastic band, which is elastic. And I try to apply it with a pressure close to 40. I try to move. 3. What can be seen is that the pressure peaks are much lower compared to the elastic material. And now I stand up, and by standing up there is a rise of pressure from 50 to about 57. And moving again leads only to very small pressure peaks with elastic material, because this elastic material will give way. So with the elastic band, we started with a resting pressure here of close to 50. And when I do dorsiflexions, the pressure goes up from 50 to close to 60 millimeters of mercury. So the difference between the peak and the resting pressure, which is the dynamic stiffness index, would here be about 10 millimeters of mercury, much lower than it was with the inelastic model. When I stand up, the pressure goes up from 50 to about 57. So this is about 7 millimeters increase of pressure compared to about 30 millimeters of mercury with the inelastic. And as I have told you, the difference between standing and the relaxed position with leg up is what we call static stiffness index. And here you see also that the peaks during standing and dorsiflexions are going up to a little bit more than 60, but the amplitudes are much lower compared to the inelastic material. With other words, the massaging effect is much lower.